prior to September. And in this one, we're going to cover off the new features that we announced when we were at our Percona Live Europe conference back 2 weeks ago. So on September 26th, we announced the 1.3.0 release. So I'll be going through some of the summary of what PMM is and how it can be useful to you, and also highlighting some of those new improvements we just made available. Okay, so just to give you some background, I've been with Percona for about 5 years. I started as a consultant on the database side, on MySQL side. I moved up, I managed the team for a little while. Then I worked in our new technical account management group, where I was working with some of our higher profile, higher revenue generating customers. And then I moved into this product manager role. So I'm able to take advantage of my past history and experience as a database engineer and to put it in front of all of us who are also database administrators or business owners and say, I think this is the data that's most important for you to make decisions against it. Okay. And I'm Canadian, you might be able to tell from my accent, but I'm actually living in Mexico. We've been here for about a year and just loving it. So why are we doing this talk? We want to make sure that we can help you with your troubleshooting of problems as they arise. It's unreasonable to expect there won't be problems in production or even before you get to production. And when that happens, you need to have visibility and be able to observe those issues. Okay, but we want to make it better than just having your other team say to you, well, the database is slow, go fix it. Okay, I acknowledge that, but where do I need to look? What actions do I take? And that is really where PMM is coming in to kind of help you with that approach. Okay, we want to make sure that this is a tool that not only do we position for use by yourselves, but we also have it in use at Percona. We use it in 2 different main ways internally. One is through one of our managed services offerings, which means Percona will take 100% control of your database environment, and we will manage your database day-to-day operations for you. Very popular product that we've positioned, and we use PMM against all of these client installations. So what that means is not only do these customers who use these services are able to take advantage of PMM, but it helps us standardize our approach and our discussion and our language that we use when we're troubleshooting issues. And kind of a nice thing on the side is it gives me as a product manager basically free bug reports and feedback. So it's really helpful that we use it internally. And the second component is that our support and consulting teams also use it. So when we go on site, we deploy PMM just for the sake of doing an audit, but we also use it when we're helping customers troubleshoot issues where they're Percona customers, but we don't have login. So we'll suggest try installing PMM, help us by sharing these particular dashboards back to us. So we find that not only is it useful if you use it entirely yourselves, but also when you're working with Percona, we can help you faster and resolve your issues more quickly if you're using PMM. So we're going to go quickly through some of the background on PMM. We're going to look at the 2 main parts, metrics monitor on how to visualize activity and query analytics. In fact, actually on this slide, I have them reversed. We're going to start with query analytics first. And then we're going to get in a little bit of a discussion on 1.3. Okay, so PMM, free and open source. Every piece of software that Percona cranks out is always open source. There's no licensing attached. Use it as you like. Now, some of these licenses have their own caveats. You need to attribute, and you can't bundle without releasing source code. But those are things inherent with the licensing models that we've chosen. GPL version 3, for example. But Percona is not asking for a dime for any software, and that includes PMM. It's here to help you troubleshoot your database and to improve the performance for MySQL and MongoDB. Okay, those are the 2 main core products that Percona represents and that PMM focuses on. But we want to make sure that if you are running MariaDB, you're covered. If you're running MySQL Enterprise or from Oracle of MySQL, then you're covered as well. And we also have support for proxy SQL. If you want to put this in front of your PXE cluster perhaps, or your MySQL cluster, proxy SQL is covered off in PMM as well. Another key difference, this is not a SaaS product. This is not running behind some application on the internet. This runs in your environment on your equipment. It's a bit of a departure from the way many companies are going these days, but we are responding to customer feedback. Customers didn't want to send their private database queries across the internet. That was a security concern, not just for the database and application developers, but also for those security teams. Why would you want to send the contents of your where clauses that may include sensitive data? Social security numbers, credit card numbers, those types of things. But we do still supply, so when you're running this on your premise, we also do have encryption when it's on the wire. So everything is bound through SSL from the client to the server. So on the wire, you're secure, but you're not sending it across the unsecure internet, okay? So The frequent question is, as a database administrator, the database is slow. Well, okay, great. But really, how do I relate that? What does that mean? What is my takeaway? What is that comparing it to? You need to understand what a normal level or normal throughput is for your database. And we call that generally a baseline. So your baseline dictates that for peak traffic on Mondays, this is what the behavior is. Is it 1,000 queries per second, 5,000 queries per second? Does that mean it's doing 1 million rows read in InnoDB per second? What is normal? And I have some graphs that can help you establish baseline and compare different time periods overlaying each other so you can see in one visualization what your baseline might actually be. Okay, but when you're talking about slowness, it's not just the baseline. You need to also establish, if you have identified it slow, what exactly is slow? Where are the areas of your database application tier that can introduce slowness or latency? So you need to look at your hardware. Is there any degradation in the RAID array? Are you using a virtualized environment? Many people these days are, whether it's abstracted through Docker or through a VMware or Amazon EC2 instance. All these virtualization technologies are really powerful, but they introduce latency. So you need to understand if that latency is coming from that tier or not. Databases are built to work on the network. So your networking stack has some overhead that's going to be incurred, whether it's through TTLs, through hops, but there could also be congestion on the network and other factors. We've got some graphs that can help you analyze if your network, at least at the network interface level, is exhibiting any problems. And then finally, your application behavior. This could mean that you've just got a higher than normal level of traffic, and higher than normal level of traffic on the application servers generally translates into more database activity, and you might be approaching some sort of tipping point. Using these graphs where you plot your trends over time can help you understand if you've reached that bottleneck or that tipping point. Okay, and so I had this on a couple months ago. I said, well, I've already got top. I've got show process list. I've got show engine NDB status. I can read that stuff myself. But that's useful in the moment, right? When you're troubleshooting a problem, when the fire is occurring right now, yes, use those tools. But what's valuable about any monitoring piece of software, and PMM in particular, is that it retains that data at a 1 second granularity over a fixed period of time, generally 30 days. So that gives you the ability to go back and say, okay, top is text only, but I can look at the factors of where the CPU is waiting using PMM. What was it like last week? What was it like a month ago? And so that historical context is much more valuable when you're troubleshooting a problem right now to understand what is normal, what is my baseline. Okay. So we're going to begin first with query analytics, and I might use just the quick phrase quan for short, query analytics. This helps you understand where in your database slowness occurs. And I'm going to start first with MySQL, but I'm also going to cover off the MongoDB that we introduced in 1.3. So starting with query analytics with MySQL, your first page gives you the top 10 queries where MySQL is spending its time. We capture this from two different perspectives. We look at this as the classically slow query. That might be for an online transaction processing environment. Say you're a shopping site. You might care about queries that are longer running than 100 milliseconds. Under 100 milliseconds, you're very happy with, and that's what your expectation is. In that environment, a slow query might be measured at 1 second or greater, 10 seconds or greater. Classic definition of a slow query. The other way to look at a slow query is given a query that might run at 50 or 100 milliseconds each, but runs 1,000 times a second, represents a significant amount of work for MySQL. So optimizing your database performance comes in two factors. One is taking that first classically slow query and optimizing through an index change or a query rewrite. But the other aspect is also taking these really frequently executed queries and saying, how can I either reduce the work that they're doing by not running them as frequently, or optimize them through some index improvement or also a query rewrite. And the query analytics tool presents both of these bubbled up to you in an aggregated format. So in the case of the view we're looking at right now, you have at your fingertips an abstract that describes what is the kind of operation that's occurring. In this case, these are mostly selects, but a couple updates and deletes make it in there. And which table is it executing against? It abstracts out the table. So in our workload, we're running synthetic sysbench workloads. And by default, it uses SB test in increments from 1 up to 100 or however many tables you choose. So it drops the 100. So it drops the integer from the string of the database name. And that makes it easier for you to say, perhaps if you're in a sharded environment, to say, well, look, all my customers have the same schema, and I might have 100 customers per, 100 schemas per server. Well, that can just tell you what category of queries are performing well or performing slowly. It abstracts out the string to the right of the table name. Okay, and then what we get here, this is probably the most valuable column, is the load column. It gives you two pieces of important information. This first load value gives you an understanding of how heavily loaded the server is. Generally, if a query is reflecting below 1, it's a query that's performing relatively well based on the frequency that it executes and how long it's running during the observed period. But the other important factor is this percentage number here. This is showing us for all of the queries that executed within this MySQL server over this 1 hour period, say from 10:25 to 11:25 today, 45% of the workload was from this one single query. So if I put my consulting hat back on, I went into your environment and you're paying me for a few hours worth of work to help you optimize your database. I would spend the bulk of my time reviewing this one query and saying, look, if I could make this thing better, if I could make this thing perform, you know, a fraction of its performance right now, I can grow the ability of your server to scale, or I can give you longer time until you need to upgrade your server. Approximately 45% of the existing capacity of the server is being consumed by this one query. So spend your time here first, okay? And then the other fields are relatively self-explanatory. This is the raw count of times per second that this query has been executing. So approaching 2,000 queries per second. And then we get the total amount that it was observed during the monitored period. So we know we saw almost 7 million times this query during the 1 hour capture. And that's about 50% of the queries that executed was this one guy right here, representing 45% of the workload. And then the coolest little thing off to the right here is the latency. When I get into the demo, you'll be able to see how these actually are a little more actionable. We get 5 pieces of data here. We get the minimum, which is the left, the max, the average, the 95th percentile, and I don't see it displayed, but we also get the median in our image. So when I hover over, you'll see those pop up. Why is that important? This bar helps you understand the range of the performance of your query. So generally, I would focus on queries that have a wide range. Why would I do that? I want to be able to return repeatable and expected performance out of my queries. If they're going to be fast all the time, or if they're going to be slow all the time. Don't show me cases where the query performs quickly, 10 milliseconds or 50 milliseconds, and then sometimes slowly, multiple seconds. That is very difficult for an application to troubleshoot and for you to show repeatable expected results out to your application users. Things like query caches get in between. Not so much the memcache, but the MySQL query cache has been, you know, potentially a problematic source to describe why you've got large variations in your response time. So sometimes when the cache is warm, you're going to see the nice low, most of your queries are going to run relatively quickly. But in the case where the server's been recently restarted or your query cache is being evicted too much, you're going to start to see a wider band here where you're going to have a lot slower performing queries within that. And that's not generally good. That's not generally what you want to see in your environment. Okay. So as we get in, I described a lot of these fields here. I'll move on to the next slide. You've got 2 main sources that you can capture when you're looking at MySQL. Your first and probably easiest and fastest to get running is to use performance schema. As of MySQL 5.6, it's enabled by default, so you don't actually have to do any extra work. The query analytics agent will detect. By default, it's using the auto, but you can override it and say, I want to use performance schema versus slow log. But it will auto detect if performance schema is enabled, and it'll go ahead and start capturing queries for you. And that's fantastic. Why is it easier? 1, because it's already enabled. But 2, when you read and write from memory, that's orders of magnitude faster, or looked at another way, less resources being consumed because you're not writing it to disk for the slow log and not having to read back that data from disk to actually do analysis. But like with everything in this world, there's a trade-off. And in this case, you get only 5 fields. Okay, so you get these generic rankings of how often did it run, how long did it take, was it locking, and how many rows were sent and examined. So the difference between these two, the application is actually seeing the sent, and the examined is how much work MySQL is effectively having to do. It's a rough measure of how useful your indexes are. A perfect world to get to would be a ratio of 1-to-1 from rows examined to rows sent. You want to say, for every time I had to look at this table and do a range query, I only had to look at the same number of rows I sent back. Those are ideally orchestrated indexes, okay? So this is good data. It's not to say there's anything wrong with it, but you can get a little bit richer if you use Percona Server, and MariaDB to a certain degree also incorporates some of these enhancements. So what you'll get additional InterDB information, you'll get information about the query cache, and not displayed in this particular query, but you also get things about how many temporary tables were used, were they temporary tables from disk or purely in memory, a whole host of really important information to help you categorize your performance of your queries. Okay, they don't by themselves tell you what to do, but they give you hints to say, are temporary tables actually useful here? Where do I make index improvements? So having this data at your fingertips is useful. But like I mentioned earlier, it comes at a cost. So if you're not ready to consume this level of data, if you don't have your slow log on, try experimenting with the performance schema first. Okay, so in the interface, what else do you get? What we're trying to do with Query Analytics is make it so that you don't have to go back to your command line or your MySQL workbench or your other tool against the database until you absolutely have to start testing out query improvements, adding an index or doing something like that. So we're getting you these relatively trivial things, but giving them to you at your fingertips. You want to see, for example, what was the copy paste version of the query. If I want to go share this with my developers perhaps, or if I want to go execute this query and check out the explain myself, you have that at your fingertips, okay? Also, we're capturing the explain for you in the classic format of this table, of this grid layout. That just saves you having to copy paste and go back to your database server, okay? So in this case, it's a relatively trivial example. We're filtering for a single value on a primary key. And so the explain is relatively straightforward. We know it's an integer field. Well, I'll show you how we actually know that later, but we know it's an index length of 4 and only 1 row is returned because the primary key is very selective on a single value. So from this explain, there's not much I could do to improve that query. The only thing might be to pack a separate index, leading with the ID field and including the C, which I think is a pad field of varchar. But there might be trade-offs with that too, because then your index would be quite wide. With the goal being, can I do the full read to answer this query from the index or not? Okay. So this tool doesn't tell you what to do directly, but it gives you the information to move forward with analyzing a slow query and deciding what to do. One of the new features that we introduced in our 1.3 release is we now give you the JSON output of the MySQL explain. This was available in a beta release, but now we're making it GA. So you get a little bit richer data coming back. A little harder from my perspective to parse this as a human, but computers love JSON. And right now, the tool isn't really doing anything with it other than displaying it. But as you can see, there's potential for us to improve upon what work we're doing. So things like the cost info, the read versus evaluation and prefix, all of this stuff are items we're going to iterate on in later releases of Query Analytics, give you first and foremost a way to filter by this. So we could say, show me the top queries that had the highest eval cost. And move from there, aggregate based on that criteria. And then later versions, we want to be able to say, hey, if this is above a certain threshold, or if you see a certain ratio going on, this is the kind of action you can take. So we're trying to turn Query Analytics from basically today, a read-only tool showing you where your problems are into a little more actionable. What should I actually do with this? What is the first step I can take? Okay, so that's just a taste of what we're going to be doing as we get into 2018. Also, we're giving you the create table. So I knew my format of my SB test table, it's an integer field, which is 4 bytes wide. That's why as we go back a couple slides here, you can see the key length is 4. That's the length of an integer field. Okay. Yeah, totally easy to do a copy paste and create table or show create table like, easy to do that. But we're making it so you don't have to go back to your tool. You get everything within one visual display. Okay. And right now, admittedly, I'm showing you just little sections pulled out of it. In my demo, I'll be able to show you how you can flow from the top to the bottom and see how all these different views tie together. What else do you get? You get the table status. Again, the important components that I pull out of this, I like to see how many rows are in here. I know that this is actually 100 million rows, but as you all know with InnoDB, it's doing estimates based on statistics. So it's never going to be exactly accurate. My ISAM it is, but with InnoDB, we're doing approximations. Okay. I also like to be able to see how long the data is, data length, actually how big the data is probably the better English way to describe it. How large is the data? And if you add the data plus the index length, it gives you the total IBD file size. It should be relatively close to 25 gigs in the server's case. Okay. And then finally, we give you the output of show indexes. To me, it's probably not the most useful. I mean, technically there are 2 types of indexes available in InnoDB, the B tree and a full text. But you probably know if you're doing a full text or not, so it's kind of redundant to display this. I think what is valuable is to talk about the cardinality. It's probably the most unique piece of information coming out of this view. So how selective is the index? We know the primary key needs to be unique, so this should be approximating the actual row count in this table, which we know is 100 million. Okay. I'll show you one other little trick. The auto increment field here shows you what the next number to be used. So you can kind of use this in a case where you're not really ever writing into it if you're just doing updates against a table. Probably a very rare case, but in this case, it applies. So the rows of auto increment are showing me it's actually 100 million plus one more row. So that's very close to the row count that InnoDB statistics is giving me. Okay, so enough about MySQL. We'll step quickly over into the MongoDB space. We're using the same interface to keep like versus like here. We want to make it so it's not a big jump to go from MySQL to MongoDB. Okay, we also did that because it's easier for us to develop without having to invent a new display. But in future versions, we are going to have to split this out because technically queries per second is not necessarily the nomenclature that MongoDB uses. So some of these things are going to evolve over time. But the premise is we're still doing the same boil it up from where is a classically slow execution or retrieval of a document occurring. So is it 10 seconds? That's a slowness worth evaluating. And then also as you aggregate and say, when we group by this ID field here, how slow is this query because of the frequency, or how much work is this query actually doing? Okay, so we're giving you the abstract again. We're giving you the same measure of load. This is a relatively lightly loaded server, so things are below 1. But there are a lot of different unique queries running. That's why our load value here is relatively high. Okay, and they're actually running kind of slowly. We're seeing around 3 seconds on average. So that's why it generates a load of certainly greater than 1, but even on a queries per second of only 90. So we're not running them that frequently. We're just running really poorly formatted queries. Okay, what you get out of it is a slightly different view. You don't have a classic, you don't really have like a copy paste that you can use. It's not the way Mongo works, but you do get an example of the query. So you could reformulate this into something you can execute and say, I want to observe directly the performance of this query. Okay, so we present that for you in the interface. You also get the JSON explain. It's so big, so you probably can't even read this font. I certainly can't. This is how large it is. It's 3 screens on my browser. So I just gave us a snippet here of the top part. But what you'll notice, if you want to go ahead and play around with this is from our live demo site, pmmdemo.percona.com, which you can launch and which I'll be using in just a few moments here as we go through the live demo. So you could see this yourself and observe how much richer the explain JSON output is from MongoDB than it is from MySQL. You don't see it here, but it gets into things like the true cost of these queries, which different query execution plans were evaluated, a whole host of really rich data. And that's also the things that Percona is going to give you the ability to filter on, sort by, and then give you hints at, when you see this occurring, here's something you might want to do. Okay. Last, I'll show you a quick way that you can get some information about the server that collects server level, like Linux level, host level information, and also facts about MySQL. And I'm sorry, I omitted PT MongoDB summary. I'll show you what that output looks like. Okay, so let me jump into the live demo here. Need to break out of my display. We'll get into the query analytics. This is the launch page. So you can all go to your own browsers and pull this up. Please be gentle. They're not the highest powered servers. So try not to generate too much load, but certainly follow along with me if the slides aren't moving fast enough or if they're a bit blurry. But you begin here at this main landing page, and you have the choice to jump into either of the 2 unique tools, Query Analytics for Quan and Metrics Monitor. Okay, we're going to begin with Query Analytics. Now, as you get into a MySQL server, you have a drop-down box. This tool is designed to look at a per server level, per instance level to begin with. We don't have any aggregation in this version, but probably later in 2017, I want to make it so that you could say, hey, Michael, that's really cool. I can look at my master and my slaves independently, but I think of my application stack as a master and 3 slaves. I really care about what is the performance across these 3 slaves, perhaps. Show me a view that gives me that. And that's something we're working to, is that you could have a tag that says, call this application 1, that group over there, application 2, and then another group, application 3. Show me aggregation across all of those servers all at once. And then I can drill down and say which server might be an outlier here, or which query is exhibiting poor performance across all of the servers. But right now, you begin at 1 server at a time. Okay, so this is the overall view. I mentioned that you can have some of these flyouts because we're using a whole bunch of JavaScript here. And as you get over to the far right-hand side, you get the metrics that we talked about, the minimum, the maximum, the average, and the 95th percentile. I don't see median showing up on this one. It might be an artifact of this query. But they give you a unique input per query. Okay, so you can see that this one has a relatively good range from 64 microseconds up to 306 milliseconds. Okay, and averages, the 95th percentile is usually what I key against to say, do I need to optimize this query? In this case, this one is 7.04 milliseconds at 95th percentile. You're probably not going to have much luck improving that with an index or any of that type of approach. When you do see a large deviation, and in this case, it's relatively large from 7 milliseconds up to almost 300 milliseconds, there's something else at play. Generally, that will be a locking condition or stalls in your disk or potentially, deadlocks or other things like that, but it's not going to be optimized through fixing the query itself. So these are some of the takeaways that you can make when you just look at, why do I have these wide ranges? Minimum maximum doesn't always describe it. Where does 95th percentile fit in there? Okay, so you look at your top 10 at the top, and then as you select one, I've selected this insert statement here. I scroll down and I see some detail about it. So I get a per query evaluation of where it's spending its time. Is it being locked? What's InnoDB doing with it? And how much are my rows sent versus rows, we're looking at bytes sent versus rows affected here, okay? I also get, okay, we were talking about earlier, we get the fingerprint, which by itself really isn't all that useful. It really just describes to you how it's been abstracted, but what the query would look like, okay? And in this case, explain doesn't really work properly against an insert. You can actually execute it, but in this case, it doesn't really have much of a value. There's no select involved here. So, but when we get into the create table, status, and indexes, they're towards the bottom here. So we've got these little roll-up windows that you can, they're closed by default, and you can view what the create table, the status for this table looks like. We talked about the row lengths and the size of the table, and also which indexes are available on it. Okay. On the MongoDB side, you get the same consistent view, okay, as we talked about with the ranges of the timing. You also get then the abstract. The abstract is a little bit different though. It describes which collection it's coming from and which items it was being filtered on, okay? So as you scroll down, you have a little bit less information available to you. That's mostly because we're not really consuming all of the value of the JSON yet and turning that into some sort of explain and giving you some feedback on it. There's no reason why we can't take, for example, let me just jump ahead here. Well, we can't jump into this and say, look, I looked at 100 documents. That should be returned up higher. Oh, actually, in this case, actually it's showing 25. So actually there's a discrepancy here. I would have expected, maybe this is perhaps it's on average. But in it, oh, this is per second. I'm sorry, I digress. So in this case, we do have richer data about the performance of the query, where we know how many documents we examine in this particular case, okay? So because this query is not running in under a second, it's taking 3 seconds to run, therefore the documents examined per second is going to be less than the total number evaluated for this one query, if that makes sense. Okay, so anyway, my point is I want to be able to collect more of this rich information and show it to you up here in the explain section so that you can do things like sort on it and filter by it, okay? And as you'll notice, you don't get the output down below of a create table or really anything about the schema. We don't have that available yet in our version. We really wanted to get the query analytics from MongoDB shipped. Our goal is to do monthly releases, and we want to make it as quick as possible. We want to stick to that release cadence. So you may not see massive releases that have a ton of new features. Instead, what we're going to focus on is a more iterative approach and say, okay, we want to get the bare bones out there and let's build upon it. Okay, at least that way, if you're able to track with our frequent releases, you're able to take advantage of incremental improvements as you go, rather than potentially looking at 1 or 2 major breaking releases that might occur, quarterly or something of that nature. Okay, and we'll have time at the end to go through questions about query analytics. Okay, so let's begin with the metrics monitor. Query analytics, I like to think of as like the unsung hero of the app. It's not as flashy. It's more useful and functional. And I think really the most value of PMM comes out of query analytics because that is the place where you can have the most impact in your environment to say, look, boss or application developer, I optimize these queries. Look at how much faster things are. Well, you need to have a way to substantiate that. And that's where metrics monitor comes in to say, let me show you how I actually improve things. Okay. And this is based on 2 other open source products. Query analytics is something that we wrote entirely, which we open source, but metrics monitor is our label for using Prometheus and Grafana, which are 2 really popular open source products right now. Grafana is the tool that we visualize the data points in, and Prometheus is the time series database and scraping mechanism to expose these metrics to Grafana. Okay, and then the intellectual property that Percona has introduced is our ability to take our MySQL and MongoDB expert knowledge and generate dashboards that make sense. Okay, so Prometheus and Grafana work against other tools, other systems. We happen to be using them in concert, but you could use Grafana directly against Amazon CloudWatch to get metrics about your Aurora RDS instances, or against Graphite, Elasticsearch. I think at last count, they might have a good 15 to 20 different data sources you could tie it into. We're only using one, Prometheus, right now, and we love it. I want to call out that we're using templated variables, and the reason we do that is it makes it so that when a host is added into Prometheus, it just magically shows up on a dashboard, on a graph, based on criteria. So if it's a MySQL server, it starts to show up on MySQL dashboards. You'll grow to love that. And when you remove the host, it gets decommissioned and you purge its data, or you just remove it from monitoring, it disappears off the dashboard. Okay, that's entirely useful. It means you don't have to do any manual edits to say, okay, I added host, I have another step to go add it to all my dashboards. That's a pain. So it's perfect for those environments where there's a lot of hosts appearing and disappearing. Okay, it introduces some limitations, particularly around the way Grafana does alerting, but that's a relatively edge case. Most people have a well fleshed out alerting environment, and PMM is not trying to play in that space, not today. That might be something we look at in some later releases, but it's a big piece of work. We looked at it, and it's hard to do that right. We don't want to be the tool that's waking you up with false positives in the middle of the night, because that does nothing more than to frustrate people. But the other side is, if we start missing alerts, that also you grow to live and die by your alerts. And so we want to make sure when we release something, it's tight, it works well. So don't look at PMM to do alerting for you today. Look at it to do your monitoring, to identification of your slow queries, and to also show you over time how things are trending. Okay, this is where we'll get into more of the live demo. So I want to be able to show you some details, or we'll begin with MySQL and how you can look at InnoDB and one of our new dashboards, our MyRocks dashboard. Then I'll show you some MongoDB stuff, really quickly step through those. And then I want to be able to get you into how you can use the data in Prometheus, in Metrics Monitor, to compare not only across servers, which I want to show you how you can say, in my cluster, what is the performance looking like across machines? But I also want to be able to show you where I alluded to earlier, hey, what is this baseline thing? What is performance right now, which everybody's telling me is normal? How does that compare to perhaps yesterday for the same time period? And how does it compare to last month? Okay, so let's jump out of this. My dashboard's already preheated. So in this case, we're looking at one of the nodes in our PXE cluster right here. Okay, this is our MySQL overview. This is generally where I would begin my day if I've either received an alert or I'm sipping my coffee, my first one of the day. So I'd want to see some of the high-level data points. Things that I care about: has this server been restarted recently? If it's less than a few minutes, that's a problem. Did you know there was a restart or not? You should probably be paying attention to that. Most of the servers we have in our demo environment, I restart quite frequently, so I'm used to seeing these things low. But I've been in customer environments where they've literally had hundreds of days uptime, and that's okay too. That means they're probably lagging behind releases, but in any case, check for that value. What's the queries per second right now? This is showing at a moment in time, and this will change depending how often I refresh it. Okay, because it's a moving average over, I think, 5 minutes. But is this to be expected for this time of the day? How big is the buffer pool, and how much of the buffer pool compared to RAM is it being used? I know these are, well, we can make a guess ourselves, right? If it's 8 gigs and it's about 50%, these are probably 16 gig hosts. Okay, and I'll show you a way. Oh, I skipped that earlier. I'll come back to how you can see that summary of the server of the Linux OS, and to evaluate how much memory is actually in it to substantiate it. The top two graphs that I look at would be the ratio here of MySQL connections. I like to make sure that my actual connections used, which is the green line, in this case 364, how close is it approaching max connections? That's really your breathing space before your emergency break of your max connections hits. And what that's going to do, if you hit that, it's going to stop subsequent connections from your application, from your monitoring service, from your cron jobs from hitting the database, and things are going to start to break. And that's going to be a problem. That could even be a problem for you as an administrator to log in and say, what's actually going on here? Now, in recent versions of MySQL, and particularly Percona Server, we have this functionality called super login, super users. So that means nothing more than you can log in past max connections being reached. Okay, But what I care about, in this case, I got really close here. I got up to 453. So I got to about 80, 90% used of my connection pools or my connection slots. So if you see a trend where this is occurring, you're going to probably hit some point where your application is going to go offline because your database can't take any more connections. The other one is threads running. This is the core measurement of how much work your database server is doing at any one point in time. And there's not really a magic number that you can use out of this to say, is this a good number, is this bad? Generally, bigger means more work is occurring. It is a measure of how much work is occurring at the point in time you ask the question. And we've improved this graph to show you a peak and an average. So within a second, the number can be going up and down considerably. Now, in this case, this is an 8-core machine, and we're sustaining a throughput here of around 300 plus. And this server isn't really doing, they're very quick executing queries. Most of them are point selects off of the primary key. So in this case, I'd say to you, you know what, that's fine. 300 is a fine number. Don't sweat it. But in your case, if you have queries that are running over a second each, and you might be running more of a data warehousing loaded MySQL, you're not going to see much return on your server if you're hitting threads running greater than count of cores, because each of these queries can only be pinned to 1 core at a time. If you've got an 8-core machine and 9 queries running, that means one of them is waiting for one of the other 8 to finish. So it's an ever-changing value that makes sense to you depending on your workload, but it's an important graph for you to see, to visualize and say, is this appropriate? Okay, so I can do this through one visualization. How does this look over time? Well, yesterday around 4 o'clock my time, it was around 250. What was different about that time then versus what it is now? Okay. In this particular case, I'm sitting on 30 days worth of history. And I've been working with this server. It's been needing a lot of love lately. So as you can tell, the workloads have broken down sometimes. Back a while ago, back about 20 days ago, we were sitting around an average of 37. So in your environment, you're probably going to see smoother ups and downs and things like that. The point is these graphs can show you some historical context on performance. Okay. We also show you some classic, what are the count of queries per second running in the server? Again, this is over 30 days, and the workload has been changing quite a bit. And it helps you also understand what kind of selects are running. Generally, your masters will see the bulk of the writes occurring, and your slaves will see reads only, particularly if you're running a bin log format of row. So this is a unique graph for you to be looking at to say, what kinds of selects are actually occurring? Are we doing mostly point selects, ranges? Are they doing a lot of joins? That kind of thing can be interesting to view over time, how that changes. Okay. As we speak about storage engines, you've got the option within MySQL, within Metrics Monitor to filter your dashboards. We've got about 30 different dashboards. And out of that, there's maybe a dozen that apply to MySQL. So you can see they're categorized. We just discussed the MySQL overview, but then you've got storage engine specific views. Okay, and then some particular ones. There's 3 that are particular to Percona Server. And I think TokiDB is a MariaDB, so I don't want to call it a Percona Server only. Okay, so what we're going to look at is we're going to look at InnoDB metrics and then MyRocks metrics. Okay, so in here, if you're ready for a deep dive, you can start to step into some key components of InnoDB. So in the case of history list length, I can see that I had some long-running queries here that were stalling things out. And the danger with long-running queries is that they can hold open views, and that means that these old views need to be checked on new writes coming in. As more and more old views accumulate, that's more and more work the server has to do. So long-running transactions lead to slower server performance overall. Okay, so you want to watch for these kinds of trends where this query ran for a long time and then cleared. I'm glad it cleared. But if I saw this thing running for multiple hours or days, that could lead to a significant performance impact on your environment. Okay, you can also see this row operations. I find this interesting to say there is some limit for how many row operations that InnoDB is going to be able to do, given whatever hardware you have. It will be dependent on the kind of CPU and the disk quality that you've got in the machine, and effectively, I suppose, also how much RAM you've allocated to the buffer pool. But the point is that you want to be able to take that number and say, is this normal? Is this characterized as regular performance in my environment, or is this abnormal? Okay, so on a 1-hour view, that's going to help you in the heat of a moment when there's a production outage, you need to troubleshoot it right away. A better view would be to zoom back out, maybe over a 24-hour, or let's even put it the last week's worth of activity. Synthetic benchmarks are very weak, right? They're not very up, and I mean, in this case they are, but this is more because I was breaking the server. Normally we get relatively flat performance here. So in your case, it'll be much richer for you to be able to say, at peak, we're approaching some sort of threshold, and watch for what those row operation thresholds actually are. A new graph that we introduced is our MyRocks graph. Okay, and this one is to help with the storage engine that we've incorporated from Facebook. They wrote a new one using LSM trees called RocksDB, and it began for them to help solve some of their unique challenges within Facebook with their workload. And they embedded it. It was part of their application. And then they realized that they wanted to split it out and make it accessible to different parts of the organization. And they already were using MySQL quite extensively. So they decided to say, why don't we make this a storage engine to MySQL? And that's what bred MyRocks. Now, Facebook and Percona work together to integrate MyRocks storage engine into Percona Server so that Facebook can focus on development of MyRocks and not be responsible for the building and the packaging and the testing of MySQL itself. So that's where the partnership really works well for Facebook. They get a partner to help them do all of the work to integrate it, and they can focus on the core bugs and features that they want. And Percona gets to take advantage of sharing this technology with other users who need LSM-based storage engines. It's a relatively unique one. It's ideally suited for heavy write environments. Okay, it's not so great at point selects. That's where InterDB still continues to excel. But MyRocks, you know, it's a bit of a niche. You might see a good, 1 to 5% of the market actually benefit from it. There is some overlap between TokuDB and MyRocks. So if you're already using TokuDB, I encourage you to explore MyRocks. It was available in our repos as of early September in an experimental basis. So the caveat is don't use it in production yet, but certainly feel free to experiment with MyRocks. It's available in Percona Server 5.7.19 that came out, I think, around September 8th of this year. Okay, enough about the history. What do you get out of it? We're able to show you some of the cache information of MyRocks' performance. I'm just using the same sysbench workload that I had against the other servers. I just changed the storage engine from InnoDB to be MyRocks. So the workload isn't necessarily stressing the LSM components. It's more read heavy than anything, but we are able to at least show that we've got some pattern of work that's occurring within this instance. So it's heavily focused in our dashboards today on the cache. How effective is the cache? Okay. In later versions of Sysbench, we want to improve it, so we actually take advantage of leveraging some of these filters. Today, we didn't have the bandwidth really just to build up the tool to do it. But if you're in an environment where you are leveraging all facets of MyRocks, you'll see actual useful numbers coming out of these two, well, actually these three components of your dashboard. Okay. So we're really excited. This is in our 1.3 release that we announced in September on the 26th at our Percona Live Europe event. It comes in the 1.3, and since then we've already had 2 releases. We had 1.3.1, which came out on September 29th, which was a bug fix only. And then we had today, if not already, in our repositories, 1.3.2 is available. So announcing on October 11th, we had a second bug fix release. We're going to be having our 1.4.0 release occur next week. I'm shooting for Tuesday. I'm really hoping we can stick to it. I'm hearing it might get delayed, but we're targeting Tuesday, October 17th for the release of 1.4. Okay, and I'll talk a little bit at the end about what's actually going to be in that one. So that's MyRocks for you. The next one is a quick overview of MongoDB, and I'll put it on a host I know that I've got a good workload running against. Okay, in MongoDB, we begin also with an overview graph. Mongo. But we have the same idea where we approach it with an overview, and we've got a little bit more of an enhanced overview here. We've got a view that you can see from the replication set perspective, so multiple servers get wrapped up. We've also got a cluster view, so it's a high-level view of what's happening within your cluster. Okay, and then you can tell it's the common approach where we have a dashboard per storage engine, so we can show you the interesting characteristics of those storage engines. So we'll begin here first with just the overview. You can see at a high level what in this particular server, and we've got all of our MongoDB servers listed, which ones or which types of queries are running here. So reads versus deletes versus inserts. Okay, we give you other MongoDB specific information about count of connections, how often is queuing occurring, are there any errors occurring, any asserts occurring? These kinds of things are available to you on the MongoDB overview dashboard. Okay, now I want to show you some of the cross-server graphs. This one here is really unique. I've already predefined it to be my PXE cluster. And I've got 2 PXE clusters, a 5.6 and a 5.7. And the workload is different. I've got proxy SQL sending queries across all 3 of them. And I've also got unique workloads running on each server. So they're showing different query patterns and also different accessing towards the Linux kernel side, the hardware side. So you can see our load average floats differently between the instances. We also have a difference in our count of connections open from MySQL. But particularly, our MySQL queries is considerably different across these servers. We've got one as low as 400 queries per second, all the way up to maybe 1,500 queries per second. You can show this if you have maybe a MySQL replication pool. You could put all your slaves into a predefined host list up here and say, what are my slaves looking like right now? And I could compare this against my 5.7 cluster at the same time. The trick is don't overload it too much, because now that view is starting to get kind of messy. Which color maps to which? There's only so many colors that Grafana is actually going to use. So try to keep it simple. But the point is you get a nice way of displaying key data of your MySQL environment overlaid with each other. Okay. One of the key components I like down here too is it gives me two pieces of information. One is what version of the kernel am I running right here? Am I ready, or am I missing any kernel updates? As you can see, I'm a little bit lagging on my PXC cluster. My 5.6 cluster. I haven't restarted them in a while. You can see that the kernel versions are a bit older, 28 versus 36 here. Okay. On the trends dashboard, this is the one I was speaking about, where you could compare performance from right now, whatever time range you've selected, and by design we're using 1 hour. Compare that against yesterday's same 1 hour period versus a week ago. So we've got the busy state of now, 1 day ago, and 1 week ago. So as you can see, a week ago, I didn't have very good load tests running for the server. My server 5.6-2, I wasn't doing much with it. I think I was ignoring it. But yesterday at least, I had my benchmarks running again. And then just now, you can see that we still, even though these are synthetic, they do tend to exhibit different kinds of performance characteristics as they're running. So the point of this one is to show you that you can compare multiple different components of your server over time to say, what is this baseline? Is right now normal? Okay, what did it look like yesterday or a week ago? Was it normal then, or did we go up or down since then? And vice versa. If it was different a week ago and things are lower or higher now, that's somewhere for you to focus to say, what's making it unique for this point in time? Why am I seeing differences in my server performance today? Okay. Two more dashboards I want to show, and these are more Percona Server specific. I believe MariaDB used to be using some of these. They had been taking in our extra DB storage engine with our enhancements. I'm unclear if they're going to keep doing that. I think they might be going to just upstream only or maintaining their own fork. So you might find some overlap where you can get some of this detail out of non-Percona Server. But I want to highlight it because it answers some relatively straightforward questions that I used to get asked as a database professional all the time, that I could collect in the heat of the moment, but it was difficult for me to visualize this over time. So we begin with table statistics. This helps you understand the largest tables in your database. It's a classic question. People just off the cuff say, well, what are the biggest tables? And it's not always the most intuitive way for you to answer that as a database professional. On Percona's blog since 2006, Peter wrote way back in the day a select statement to aggregate this data from information schema.tables. And that's what we're doing. But we're able to keep doing it for you. So you don't have to just do it when somebody asks. It's always updated for you. Now these are synthetic, right? So these numbers don't change a whole bunch, but in your environment, they probably will. And you can see clearly that we're doing some rounding, obviously, but we're very much closer to the true number. My ISM knows always how many rows are in there. InnoDB is always based on statistics. So even though these are both 100 million, we're lying a little bit here with InnoDB, okay? So we're doing it by row count and also by the size on disk. Okay, so this is using what InnoDB is reporting. So it's not actually doing a DF on the file system or anything like that, or a DU, but it's actually using what information schema.tables is telling us about the size. Okay, so that's cool. That tells you one server at a time. But in this case, it's showing you how that database size has grown over time. This would be interesting to you maybe on a 30-day perspective for your environment. My workload doesn't introduce a lot of new writes into the tables. So even if I set this thing to 30 days, I don't think we're going to see a dramatic change. Unless I've had to refresh the server, it might have gone up and down in that use case. Okay, and while that's loading, you can also see this is where the really neat meat and potatoes, I think, of the Percona Server working with a user stat variable. Why this is unique to Percona Server. User stat gives you the ability to see which which tables have the most rows read. This answers the question, which are my most active tables in MySQL? I'm not aware of really any other ways to do this. You could maybe figure this out through the slow log by saying, okay, I saw this table and I saw this many rows got returned from this table, or rows examined on that table. But boy, that would be tricky to do. You'd have a lot of code to write to do that. This is answering it right for you here. Clearly, my busiest table by far is this InnoDB SB test 1 table. Most of my work is occurring there. Okay, that's really cool. You might not know that your users table or your payments table or something to that effect is your busiest table. Why is that important? Well, as we looked at the top about the size of the tables, that has impact in things like backups, alter tables, how long are they going to take? Generally, the larger these tables are, the longer these types of operations are going to take, and potentially cause you the most pain in terms of slowing down the environment because triggers are executing, or because a lot of changes are occurring in the table. But also by looking at the activity that can help you with, sometimes when you use a tool like PT Online Schema Change, it doesn't always execute as quickly as expected because it has to get locks to put those triggers on there. Well, if a table is really, really busy, you might be blocked from getting those locks to put the triggers on. And by waiting to get those locks, you're blocking traffic against the table. So it's a chicken and egg problem. This display here of the, I'm sorry, I'm scrolling on the wrong one. This display of the rows red can help you understand if now is a good time to do that PT Online Schema Change on that big table, or maybe wait until some other slower period, maybe at night, middle of the day, somewhere else, as you can see in the graphs as it goes up and down. Okay, so as we discussed the rows red, we've also got an understanding of which tables are taking the most events of changes to them. And so that's going to be inserts and updates against those tables. Okay, so that helps you understand where the activity is across your tables. I'm not sure of how else you could do that without a tool like UserStat. And then finally, this one doesn't happen too often. You need to be in a relatively rarefied space to have it occur. But what happens when you run out of possible integer fields? You know, you hit 2.4 billion if you're using unsigned. If you're using signed on an int field. That's a lot of rows, right? But you might actually get there for some sort of edge case. So how close are you to that? So it's just kind of a nice little show it visually. How close are you to exhausting your auto increment? And the last one I want to show is another component of UserStat. It's the user statistics. This helps you understand which application users in MySQL are causing you the most work. So if you're using only one login user to do all of your database activity, you're not going to get a tremendous amount of value out of it. But I've seen a number of shops, particularly Ruby on Rails, tended to follow this, where a new module will be released for a new feature, and there might be hundreds of modules, and each module would get their own read only and read write user. And that would be immensely rich data to use against the user stat. So I could be able to say module ABC read-only user is doing 80% of the connections created, or that much of the traffic that's occurring in the database. In our case, we're only using one user, SB test, so the bulk of the work is occurring from that user for each of these different criteria. But in your case, it might be a lot richer than that. And it's helped me understand that, why is my root user logging in here? I wasn't aware I had any root level activity going on. So it helps you say not only who's causing me work, but who's in there that shouldn't be in there? Are you seeing development accounts or just accounts you don't recognize? And is it causing me work? Is it that cron job that was written 5 years ago and I should probably go and dig into that and make it go away because it's costing me CPU time or something to that effect? Okay, so let me pull this back up here. Okay, and I showed you these. I didn't do the query response time one, just because I'm running really, there's only about 5 minutes left. I want to highlight that there's three for you. It comes in Docker, a virtual appliance, and AWS formats.
Oh,
so
Michael,
Docker is probably the most common.
Sorry, can you repeat that? You cut out on the highlights a little bit.
On the highlights of the distribution methods?
Yes.
Okay. So the three main distribution methods, as you can see on the screen, the advantage of using Docker versus virtual appliance and AWS, the advantage of Docker means that you can easily get it deployed in your environment on virtually any Linux installation or distribution out there. It's distribution agnostic, okay? And the advantage is it's all packaged up into one Docker container for you. So upgrades are relatively trivial. You can do it in as little as 3 commands and not lose any data. And I've got it down in our demo environment. I can do it in 10 seconds or less. So 10 seconds of downtime means I have 10 seconds I don't have any data points, and that works out really well. That's generally acceptable. So Docker, but we don't do it the Docker purist way. We've only got one container where probably we should be thinking about doing it as multiple different Docker containers. But we do it this way because it simplifies deployment. We're trying to make it easy to get it into your environment rather than making it, okay, here's 50 steps to make sure all your containers are up and check this and check that. Our Docker deployment is intended for simplicity. But if you're running a larger enterprise environment, maybe with VMware or Microsoft System Center or Red Hat's virtualization, we have a solution for you. We've got this OVF format, which is a shared format that many companies have agreed to say, this is how you distribute virtual appliances. I use this all the time with VirtualBox when I'm giving demos to different customers and things like that, or at conferences. Okay, so we have the OVF, which should work for you as well. And then the third is an AMI image, which you can clone right now from any of the 14 regions. I'm not so impressed with that. We're going to improve upon it and make it available from the AWS Marketplace, so it's just a point and click. But we want to make it so it's easy to get into AWS and not have to do it Docker there. The reason I highlight these three is that we don't have an RPM-based distribution method, and we're not really focused on that. Our goal is to keep it simple to deploy. So we may consider it down the road, but today we're not focused on DAB or RPM. We want to keep it at 3. As we would increase to 4 or 5 distribution methods, it'd be more complex for you, and also for dependency checking, and also for our support team to help you when there's problems. Okay, so we're going to give a few minutes at the end here for some questions, but I want to remind everybody, Percona is going to be sponsors at the Amazon AWS reInvent conference at the end of November. I'll be there for 3 days at the exhibition hall. So if you are going to be in attendance, come on in. I'll be doing demos all day long, and I would love to hear your PMM experience, what you like about it, and what you found challenging, and if you have any future requests for us. So thank you very much. Emily, I'll turn it back over to you.
Awesome. Thank you so much for that, Michael. At this time, go ahead and enter your questions down in the questions field. Michael, are you able to stay a little bit late? We're almost close to the top of the hour.
Yes, I'm available.
Okay, awesome. All right. Our first question is, do we have an option or a choice to kind of select only MySQL versus Mongo monitoring and PMM, like enable or disable kind of type functionality?
The way the system works is you install the server in a single location, and then you install the clients on each of the servers you want to do monitoring against. And you, at that point, decide what services you want to monitor locally. So you're going to do an add command to say, I have MySQL running here. Go ahead and monitor these MySQL boxes using these credentials. And the same goes for MongoDB. I'm running MongoDB locally, or Proxy SQL, or those kinds of technologies. So that means that data will start to show up in the dashboards, in Query Analytics and in Metrics Monitor for those technologies as needed. What you'll find, though, is in a common deployment, all of our dashboards are shipped, all 30 of them. So if you're saying, and this is a feature request I've had and I think we want to improve on, if I'm a MySQL only shop, why do I consistently see these MongoDB dashboards showing up when I upgrade? And I want to fix that. I really only want to have dashboards show up. I'd rather ship you an empty Grafana, empty metrics monitor, and only when you do add MySQL do the MySQL ones appear. Something like that, to just keep it a little thinner on the eyes. So thank you for the question.
Awesome, thank you. Our next question is, if we have hosted Graphite solution, could we integrate it with PMM and metrics for a single location to review? And if so, how do we do this?
In theory, you could. The advantage of PMM is that we're using effectively just stock Grafana and stock Prometheus. So if you have a hosted Graphite, and if I understand this correctly, you've got the storage metrics being accumulated somewhere else, some other endpoint. Well, then you could technically deploy PMM in your environment and configure the PMM Grafana interface to say, hey, I've got that Graphite data source out there. Go and access it, pull in these dashboards, and now within PMM, I can monitor my local Prometheus, MySQL, and MongoDB stuff, and also whatever I've got in the Graphite remote location. But from a how to do that, we don't have any how-tos or blog posts yet on that specific topic. But I would be very interested in working with you if you maybe want to share an email back to myself, michael.coburn@percona.com. C-O-B-U-R-N, and I'd be happy to work with you. We could co-write a blog post on it, or even I could do a proof of concept on it and show you how it would work and then publish it together.
Awesome, thank you. Our next question is, how can I set up PMM to analyze database servers from multiple data centers with PMM server located on one of them? Or do I need to have PMM server on each data center?
That's a really good question. How do you handle the latency between networks is the concern I have. How close are they physically located? So if you're, the reason is, Prometheus is by design going to try to scrape all of these metrics, most metrics, every second. So you need to have that round trip time for collect of the metrics and get it back into Prometheus under 1 second. Otherwise, you're going to start discarding metrics because they're overlapping and they're not getting accomplished in time. So if your latency is relatively low between data centers, you could get away with having one PMM at your main location, let's call it, and reach out to these remote spots. And that would work. That would work out fine. You could also change the scrape interval, and these are Prometheus specific things, but they're available when you configure, when you launch PMM using the Docker container. You can stipulate a longer than 1 second scrape interval. So you could say perhaps 3 seconds or 5 seconds. You lose the granularity, so now you're only seeing, you know, the 5 second rolling average kind of view of the metric, but at least you're able to get your scrapes done more within the time period. Hopefully your TTL is not as high as 5 seconds. That's one way to do it. The other way would be to do a PMM per data center. So that would keep everything local, you know, land speeds and everything would scrape within 1 second, no problem. But the drawback would be that you might have multiple URLs you'd have to access. In the long run, we haven't put much effort into this yet, but I would love to see a tiered approach. This is how Prometheus is designed to work, where you've got multiple data center deployments, and you have one PMM server per data center at a very low resolution, 1 second, and you might have your main data center a roll up, so one that scrapes all of these other Prometheus into one master Prometheus at some lesser frequency. So then you could see across all 5 of my data centers what is the 5 second or the 15 second averages. And that's how you would achieve a scaling of it, where you have Prometheus scrape into itself at a higher level, and then look at one main server at an overall view, and then as needed drill into the specific servers. So that's a dream I have for 2018. It's available to you because Prometheus supports it to do this kind of scraping, but it would take a bit of work with the graphs and data sources. But if you're interested in doing it and want to be a partner with us, I would love to help you get that deployed. So again, reach out to me or reach out to Emily, and be happy to work with you.
Oh, thank you. So our next question is there a way to tell which database the query has been run on? For example, if I have identical looking queries that are run against several databases with the same schema but different data, what do I do?
So by design, you're going to be looking at one server at a time. So you already know that the queries I'm examining here are happening on this one server called PS57. So what we're missing, I think, is information about which application user or which MySQL user executed the query. And unless you happen to get lucky with the example, right here it says a specific table name, SPTest1. This might have been inserts all across, you know, SPTest 1 through 100. And in your case, you might call that customer ABC, customer XYZ. So that matters to you. But to me, in my synthetic tests, I don't really care that they all get abstracted away, but you might. So Query Analytics doesn't give you that resolution to say which particular schema, if the schemas are all named similarly, did this actually execute against. So the answer is, if you really needed to dig that, you'd have to keep the slow log around and review that on a one-off basis, whether it's a big grep or something like that.
All right. Okay, I'm going to squeeze a couple more in, and then, guys, I'm going to start recording all of this because we are a little over on time. Our next question is, how good is the metrics monitor with MySQL RDS? Does it get the data from CloudWatch as the data source only?
That's a really good question. No, with RDS, it presents itself as a pure MySQL server because it is built on MySQL 5.6. So the advantage is that you can get relatively all of the MySQL metrics back that you're used to seeing. So in my demo environment, it's on my to-do list to actually get an RDS box in there so I could demo this, but it should show up under all of the regular MySQL overview graphs and see key things like how many connections are running, threads running. All of this data should be available to you from RDS. That's probably a good segue though, because in our big 1.5 release, as we're going to be presenters at AWS reInvent, our 1.5 release due out in November is going to have a large amount of improvements around AWS, RDS and Aurora specifically. We want to make it so that it's native. Right now, we've got dashboards that you can connect for Aurora, but it connects directly against CloudWatch. The data doesn't live in Prometheus, so you can't really get great historical past whatever Amazon is sitting on. And if you want to get historical, it's costing you API hits and things like that. What we want to do in our 1.5 release is make it so that you have all of your Aurora and RDS data is stored in the local Prometheus box, and all of those metrics that you can capture not only from the MySQL exporter, where we're getting MySQL specific data, but Aurora comes with its own set of API pieces of data that you can collect back using the CloudWatch exporter. So we're going to add CloudWatch as a running exporter to collect that and store that in the local Prometheus instance. So watch for us to have a specific Aurora dashboard, just like we do for all the other MySQL storage engines, and it will help you with your key characteristics of your RDS and Aurora deployments.
Thank you. Okay, our last and final question. Don't worry, guys. I've got your questions recorded. Any plans to add Percona Extra Backup to the PMM dashboard?
Personally, I really want to see that happen. There's not enough of an appetite, I'd say, within Percona to do that, given our other priorities. So I'd be interested in hearing specifically what you'd want to see in there. My view of it, I'd like to see when backups are starting and stopping, so that I could see over time how long are they taking, did they error out, those kinds of conditions, I believe belong in this platform. Part of the reason we haven't really got to that is we're focused on improving what's there first. So we want to make this a quickly released, a highly iterative release cycle and cadence for PMM, and improve the quality of what's available before we broaden the scope too much. So watch for us to make 2018 more about the second M in PMM, the management side. Today, we're really focused on the monitoring, and I get that extra backup falls into the monitoring, but that would be a new component, a new feature, maybe a new exporter, and a good piece of new work. So I think in 2018, we're going to be ready to bite off much more of that. I envision that we're going to have a much larger managed backup solution. So not only can you visualize what PXV is doing, but also can you trigger a backup from here? Can I see historical backups? Can I do a restore from the interface? Why doesn't PMM do that for you? Why doesn't it satisfy all of those management components that you do on a regular basis for your MySQL deployment? 2018.
Awesome. Well, thank you so much for that, guys. And thank you so much, Michael, for presenting today. We'll probably get another PMM webinar scheduled pretty soon, so stay tuned, guys, and expect an email from me shortly with the recording and the slides. Yes, and also you can add all of your questions and comments on the blog post as well. So if you guys think of more, you can always leave comments on any of our PMM blog posts. Thank you so much, everybody, and thank you, Michael.
Thank you, Emily. Thanks, everybody.